that this is the simple way you can do it. It is hiding this particular part. I think you can see it now. So the syntax of writing a dictionary is that you have to write the key and value. Key value means what? I give a simple example. Suppose resistance. So resistance is key and you can write its value. You can write key means it may be current, you can put the values. Voltage, you can put its values. Inductance, you can put its values. So whatever parameters is coming into the experiment, each and every one has its own name. Names are called key, and corresponding parameters, that means values that you are getting in your experiment or that is already there, that you put it as value. So within curly braces, you write your parameters like this. First write the name of the parameters, then with colon you put its value, then comma, the next parameters like this. So I have created a dummy kind of things. I have created a dictionary called parameters, and I have put curly braces over here. The first parameter I'm writing within inverted comma parameter 1 colon, I'm putting the value 1. Second parameter, I am writing its value 2, and third 3 like this. Now I want to check what is the type of this variable called parameters, which I've used as dictionary. So it will give me the result dictionary, and I want to see exactly what exactly inside these parameters. So I write it. So run it. So it is telling me this new data types parameters, it belongs to the class dictionary, and the first elements of this dictionary is parameter 1 and its value is 1. The second element of this dictionary is parameter 2, its value is 2. Third element is parameter 3, value is 3. So this is how you have to create a dictionary, and that is very helpful in doing some of the coding which is having some experimental parameters. I skip this particular part. This is telling you how to write print your results. Just have a glance. It is a nice way. I have formatted my prints command, and it is giving me that parameter 1 is equal to 1, 2 is 2, 3 is 3. Now, how to have new values? It is not like tuples, it is not immutable. You can modify your dictionary. Suppose first element, the value was 1. Now I want to change it to the value A, and second element I want to put it value B, and like this. So what I will do, I will write parameters, that is the name of the dictionary. Within square bracket, I will write which particular elements, that is parameter 1, and what you want to modify. I write like this. Second one like this, like this. I want to modify, that is I want to make a new entry at the 4th positions, because in the previous one it was limited to 3. Now I want to add a new element, so I write it parameters. I give it a name parameter 4, and I give it a value D, and see the result. So my list has been modified. Parameter 1 is A, 2 is B, 3, 1, 3, 4 is D. 3 has not, the third element has not been changed. That is why it is remaining as 3. So that's all about your dictionary. Then I'm coming to the most important part of any programming language, that is called functions. In Python, In Python, you define the function with this particular syntax, that is def, then you give the function name, then you give the arguments, then colon. Then there is an indentation, that is a space. Then you write what you want to calculate, and whatever result is coming, that if you want to send, write return that result. Let us take an example. I have make a simple test functions, def func test. I'm not giving any arguments here, just I print test and I want to check it out. So it is simply writing test. Now suppose I have defined a function called func01 and I'm giving a variable called s. So what I want is that this is a string s and it will tell how many characters are there. So I want to calculate the number of characters. So it will print the command print s has string len s character. Now what is len s? Len is a function that calculates how many number of elements are there in a list. Let us give an example. Suppose I create a list, very simple list, which you have seen earlier also. So this is a list of element 3. So if I write len a, it is giving me the answer 3. So len is a kind of functions that counts how many elements are there in a list. So if you write instead of len, if you write hello, so it will count 1, 2, 3, 4, 5. 5 elements are there, so it will count 5. So this is how I want to create a functions. Whatever word or letters I will give there, it will calculate the number of letters inside it. So this is how I've created the functions. Suppose my word is Python. So I write s equal to Python and I call this function func01 within bracket s. So s is your Python and I want to see how many letters are there involved. So I done it. So it is giving me the Python has 6 characters. So basically by using this command len s, I'm calculating how many letters are there in a particular words. Suppose I want to calculate, I am giving a number and I want to calculate squared, cubed and fourth power of a numbers. So I define a function def func powers x and I want to return its value as x squared, x cubed and x to the power 4. So when I call the function and I put the value 3, so it will give me the answer like 9, 27 and 81 like this. Now I can unpack the 11 numbers also. This is possible. Suppose this is giving me the 3 values like this. So I write it x1, x2, x3 that is equal to func power 3. So when I write print x2, that will give me the answer 27. If I write it suppose 3, it will give me the answer 81. That's all. So this is some of the examples I have given. So I move little fast over here because I have another topic to start with. This is another way you can define your function, that is called lambda functions. Here we are not giving any name to the functions. We define it. Suppose I want to calculate square of a numbers. So I define it like a f1 lambda x. X means your independent variable. And how do you want to calculate? It should be x squared. So this is the simple syntax of defining a functions with the help of lambda functions. This is equivalent as def f2x return x squares. So when you give a particular argument, say 2, for this function f1 and this function f2, you will get same result, 4. So there is no difference between this way of writing and that way of writing. But we prefer this way of writing many times because for simple functions, this is most preferred for the people coding programs. There is a function called map that makes element to element mapping of elements. Suppose I have defined a function lambda x equal to x square, and I want to calculate x values for all the elements in the range 4. So if I put map, then it will do it. So map is an iterator, so I have to put list and it will give me the result 0, 1, 4, 9. So similarly, I can define factorial of a number. This is a demo. If you go through this, my lecture notes, you can understand how we have defined these functions. I have given a number and I have defined a variable f equal to 1. For numbers from in the decremental orders n to 0 with the step value -1. So first value, if it is 5, then next value 4, 3, 2, like this, and it is taking into account all the product terms and giving me the results f. So let us check it out for factorial 5, 120, or if I take it suppose 6, sorry. So it will give me the other answer 720 like this. So this is the basic way of writing any functions. You can try it home. Yesterday we were doing some problems on suppose this is a problem. We have a point specified in cylindrical coordinate r theta z, and we want to know the distance between the points. The simple way you can do it is that we convert this coordinate r theta z into Cartesian coordinates like x r cos theta, y r sin theta. Then you calculate the distance under root x square y square plus z square. Now, if you want to make a functions like this, which will give me, that is, if you give the values of r theta and z, immediately it will give me the distance d. This is how you can create a functions like this. Since I don't have much time, so I cannot go in details about how to do the functions, but you can understand what here. First line I have calculated x, and the second line I have calculated y, and third line I have calculated the distance. And my arguments r theta z are given as an argument, values of r theta z are given as an argument into the function this one, and d value it is returned from this function. So once I call the function func with the value r4, theta 30 degree and z 10, then it will calculate the distance, and I can print it the result like this. So distance is given 10.77. So that's all for the first lectures, and I acknowledge that I have been guided by the two books, Computational Physics by Mark Newman and Scientific Computing with Python by Robert Johansson. Most of the examples in these lectures, these are taken from these two books, and I've also taken the help of some of the video lectures which has generated interest in my subjects. I hope you will also be benefited if you go through these two books. That's all for the first lectures, basics of Python programming. Next, I want to start NumPy. Kolan, can you hear me?
Yes,
Kolan, can you hear me?
Yes, I can hear you.
Is it all right? First one?
Fine.
Okay. So I'm going to start the next one. So an overview of NumPy arrays. So my agenda here is that first I will talk about advantage of NumPy. Then I will tell you what is how to import NumPy. Then I'll discuss about NumPy array objects. What are the data types? How to create arrays, indexing and slicing of arrays, NumPy functions, and vectorized expressions. I don't know whether I'll be able to finish all these things. If it is not possible, I will carry over this one tomorrow. NumPy, as you know, it is a numerical backend for nearly every scientific and technical library for Python. And it is an important part of scientific Python ecosystem. I explained it in the yesterday's lectures that what are the Python ecosystems. These are NumPy, SciPy, scikit-learn, matplotlib, SymPy, and pandas. Now there are two important packages, that is SciPy, which contains all the functions of numerical analysis like differential equations, integrations, and so many kind of things. These are there in SciPy package, and SciPy package cannot be run without the help of NumPy package. So NumPy package is an integral part of all scientific calculations. So it is the backbone. That is why it is called backbone of scientific computations in Python. This is a very important Python package. And the word NumPy it is acronym for numerical Python. That's why it's called NumPy. And if someone is very much interested about knowing NumPy, then one can visit this website numpy.org. Now, what is the advantage of NumPy? NumPy is extremely fast compared to core Python. What we have discussed so far, that it was core Python, but for ordinary purpose, probably you will not find any difference between using core Python and NumPy. But if you are handling big projects where huge data are involved, definitely that will make an advantage, because if in core Python, if you are working for 1 hour, probably in NumPy that workload will be reduced to say 10 minutes or so. I'm maybe wrong, but that is how you can make some comparisons. That is, your computation time will be substantially, it will be reduced. That is why it is always advisable to go for NumPy of fast calculations rather than core Python way. And many advanced Python libraries such as SciPy, scikit-learn, and Keras. Keras is a package that is used for artificial neural network analysis. They are using NumPy libraries. So if you are working with artificial neural network or doing some numerical analysis kind of things, then which you are using scikit-learn or SciPy, then without NumPy you cannot proceed. That is why NumPy is an integral part of this analysis. And NumPy comes with a variety of built-in functionalities, which in case of core Python, one has to build the custom code. I am trying to give you a very simple example over here. Suppose I want to add a number to each element of a series. What is your series? I have the series, say, from 0 to 1 lakhs. So I want to create a series from 0 to 1 lakh with a step size of 10,000. And what I want to do is that I want to add a number 2 to each element of this series. And I want to put it in a empty list called sum. And let us check it out. So this is the answer. That is your sum. This is the initially you have created a series from 0 to 1 lakh with a step size of 10,000, and you have added a number 2 to each one, and it has taken the time called, I don't know exactly this unit, but whatever is the unit, arbitrary unit that is coming, giving me the this calculation has been done in this time. Maybe microsecond or millisecond, I'm not sure about it, but this is the time it has taken to complete these calculations. But if you want to do it in a NumPy way, what we will do in NumPy, like range functions, there is a function called arrange functions, which will do the same job as range functions, that it will create numbers from 0 to 1 lakhs with a step size of 10,000. And I want to add the number 2 to each elements of the series, then I will write the simple code sum equal to x plus num. That is, x is the series and I'm adding the number 2. So what it will do, number 2 will be added to each elements. The syntax is this one, and if you run it, it is giving me the answer, same answer. So it is giving more time here. So some small numbers you cannot distinguish between the two numbers, but in a trial and error way one can do. I have tried it. So, but one thing is very clear. Here you have to write a for loop for doing these calculations, but here you have to write a one-line code. That is, you have to write the series and then you have plus the number that you want to write. So coding becomes much simpler if you use the NumPy array, and you are getting the same answer. I am giving you another example. That is what you are doing. You are finding the sum of squares of first 1 lakh element natural numbers. So the code something like this, x in range like this, sum you are calculating the squares and you are putting it into the sums. You are calculating the sum and finally you will calculate. This is the answer. And in NumPy way, what you will do, in a NumPy there is a function called sum. So np.sum means you are calling the function from the NumPy package, and NumPy you have called it as alias np. So you are writing np.sum, and what you want to do, you have to take the sum, you have to first square the elements x, then you have to sum it. So this is the syntax, and you run it and you will get the same answer. Something is going wrong over here. Something is wrong over here. I have to check it out. So every time when you want to take use of NumPy, you have to import NumPy as np in short. That is a big puzzle for me. It cannot be -1. I have to sort it out. Without wasting time, I'm just moving forward. I will look at it later. So this is how you have to import your NumPy. So in order to use NumPy library, we have to import in our program. And by convention, NumPy module is imported under the alias np. So you write this code, import NumPy as np. So this I have done it. So my NumPy is now there in the programs. Now first let us try to introduce your NumPy array objects. What array objects are there in NumPy? Now let us say NumPy's main object is the homogeneous multidimensional array. So it is a table of elements, and elements are basically numbers, all of the same type, indexed by a tuple of non-negative integers. And in NumPy, dimensions are called axes. Let us explain it. Suppose this is a two-dimensional array. These are all columns 0, 1, 2, 3, 4 in the row 0, 1, 2 like this. Rows are indexed as this is called axis 0, and columns 0, 1, 2, 3, 4, this direction is called axis 1. And this two-dimensional, if there are more tables like this, and if you stack one after another like this one, suppose this is one table, behind it there is another table, behind this one there is another table. So the direction along which this stacking is taking place, this is called axis 2. So altogether there are 3 dimensions in this particular representations. Axis 0 defines all the rows 0, 1, 2, 3 like this. Axis 1 stands for all the columns 0, 1, 2, 3 like this. That makes a two-dimensional array, and the direction along which two-dimensional arrays are stacked, that is called axis 2. So up to 2 dimensions, 3 dimensions we have explained. Suppose I have this example 1, 2, 3, 4, 5, 6. So this is the direction of x is 0. This is the direction of x is 1. This is a two-dimensional array. So x is 2 is absent over here. Now, NumPy's array is called ND array. Class, the name of this class is called ND array. And some of the attributes of this ND array are ndim, that will give you the answer how many dimensions, that is x's, are present into the array. Shape, that is how many elements are there in this array. Say for example, if it is a matrix of n rows and m columns, the shape will be n by m. Size, that is total number of elements in the array. That is, if it is a matrix of n rows and m columns, then shape will be nm. Elements presence will be n into m. D type, that will tell you what is the data types of this array. And n bytes, number of bytes used in the stored data. Let us take a very simple example. So I have created a data of array like this, 1, 2, 3, 4, 5, 6, like this. So once I run it, it is giving me the answer that this data, it belongs to the category NumPy ND array. I want to know its dimensions. So I write data.ndim. It is a two-dimensionals. It has rows and columns. What is the shape of this array? Shape of the array is 3 by 2. 3 by 2 means there are 3 rows and there are 2 columns. 1, 2, 1, 2, 1, 2. And this is 1 row, 2nd row, and 3rd row. So 3 rows and 2 columns. So shape is 3 by 2. What is the size? There are altogether 6 elements there in this array. What is the data type? There are integers. What are the number of bytes it has taken? So it is giving 24 bytes. Then in NumPy array class, which I have told just now, in case of a list, lists are inhomogeneous. It may contain any type of variables, but NumPy arrays are very much strict in this manner. They are homogeneous in type. Homogeneous data type belonging to the NumPy array are, they may be either integer or unsigned integers, Boolean type, float type, or complex type. So here there are some examples which demonstrates how to use D-type attribute to generate arrays of integers or float or complex values. Say for example, I have a list called 1, 2, 3, 4. From list I can generate an array. The way it is done is that the list you define within square bracket and you put it within first bracket and write what type of array you want to create. So you write D type equal to integer int and put np.array, that will generate an array. So it looks like this. Array 1, 2, 3, 4. If you want to create an array of floating type variables, then just instead of int, you write float. So now your array is of floating types. If you want to create complex type, then it is, you write D type complex. Now once a NumPy array is created, its D type cannot be changed other than creating a new copy with typecasted array values. Say for example, I have created a data type array with 1, 2, 3, 4 and data type is float. All right, it has been created. I want to see the data. It is array of floating point variables 1, 2, 3. Now I want to see its data type. It is a float 64 types D type. Now suppose I want to create another array with the help of this array data, but nature or type should be of integer type. Then I have to write it like data D type integers. Now check it. Now it has become an integer type data. So this is how you can change from one data type to another. So earlier I have created a data type of floating point variables. Now by this change, I have created an integer type array. We can use AS type also. That is also done. These examples are here. One can try it out. So in AS type, what you have to write? AS type within bracket, what type of variables one? If it is integer type, just write int, then it will be created. Now, when computing with Numpy arrays, the D type might get promoted from one type to another, and if required by the operations. For example, if you are adding float valued and complex valued arrays, the resulting array is a complex valued arrays. Just like we have discussed the same thing in discussing with Pythons. That is, if there is two types, integer and float, most general type is float, so result will come in type of float. If it is a float and complex, then result will come in the form of complex. Similar kind of things happens here also. You have created an array of numbers which is of floating type and another array which is of complex type. Now you want to sum these two array. You write it like this. You have got this result D. Now you can see that result is of complex type, because if you compare float and complex, complex is of more general type. So this array, which is of floating point type, that has been promoted to complex type, and result is in complex type. You can check it out. So it is complex type. Now, depending on the application and its requirement, sometimes it is essential to create arrays with appropriate data type. Say for example, I have created an array of 3 numbers -1, 0, 1, and I want to take square root of these numbers. And here I have not defined anything. This is integer type. Then this, what problem it arises, you see. It is everything it is done, because if you take square root of 1, it will be 1. If it is 0, 0, but what about -1? If it is a floating point or integer type, square root of -1, it will give some errors. But if you mention that data type is a complex type, and if you take square root, then it will give the answer. It will give the answers. The first one, 1, so 1, imaginary part is 0, 0, answer, square root is 0, imaginary part is 0, and -1 square root, it is j, or imaginary numbers, so it is 1 into j, real part is 0, so it is giving perfect answers. So depending upon the need of the calculations, sometimes you must be specific about mentioning this data type in your array. And how to extract the real and imaginary parts from an array if it is a complex type. Suppose you have an array of 1, 2, 3, data type is complex. So this is your data. Now if you want to extract the real parts of this array, then you write data.real. It will give 1, 2, 3. Yes, it is given. And if you want the imaginary part, it will give all